Testing 1, 2, 3.
Testing
Chapter
1,
7.
2, dealing with one of the techniques we can use for making economic
Again,
decisions.
looking at our big picture,
here's an example of a series of cash flows where we have more than one sign change in the direction of the cash flows over the useful life. This is one of the types of situations where we have to make some adjustments in order to get a realistic answer. If we solve for the unknown interest rate using the equation the net present worth equals 0, in this particular situation, we can find that there are two solutions that set the net present worth equal to 0, 10.2% and 47.3%. The reason is because when we have more than one sign change, the solution equation ends up being a polynomial with two roots. And so we get these two roots that aren't really very realistic. So we need to do something to make some adjustments so that we can get realistic answers. To expound on this situation just a little bit more, when we create a polynomial so that we could solve for the internal rate of return, the number of sign changes has a lot to do with how many real roots we could have. And we really only want to have one useful number when we're done. In short, there may be as many positive values of the interest rate as there are sign changes in the cash flow. We do actually have situations where we have 0 sign changes, and that's where all of the cash flows are either money coming in, such as receiving gifts, or money going out, where we are giving loans that are not going to be repaid. In that case, we can't compute an interest rate because there really isn't one. So what we're going to do is solve for the rate of return or internal interest rate using what's called the modified internal rate of return, or MIRR. This method adjusts the cash flows so that we only have one sign change to deal with. What we do is we aggregate all of the up arrows as receipts, money coming in, and call that RI. And we aggregate all the expenses, all the money going out, as EI. We find the present worth of the expenses using what we call the external financing rate, which is a realistic rate for money we might borrow to use to pay for things on time. And then we use what we call the external investing rate to find the future worth of receipts. And the external investing rate is a rate of return that we might expect to get if we were investing in the future at a rate attractive to the company. So what we end up with is one present value and one future value. And so from that, we can solve for the unknown interest rate, and we call that the modified internal rate of return. So here we have an example with two sign changes. First, we have an expense of 4 million, and then we have income for 4 periods. Those are the up arrows you see, and then we have expenses or cost in the last 3 time periods. So we have two sign changes, one between years 0 and 1, and another one between years 4 and 5. This series of cash flows, if we simply solve for the interest rates that make the net present worth equation equal to 0, we get the two real roots of 4.73% and 37.2%, neither of which is realistic or useful. So using our MIRR technique, we are going to take the 4 down arrows, the 4 expenses, and bring them all back to time 0 using the external financing rate that we choose. And we're going to take the 4 up arrows, the 4 incomes, and find what their future value is using the external investing rate that we choose. Then once we get a single cash flow at year 0, a present value, and a single cash flow at time period 7, a future value, we can then solve for the internal rate of return that makes the net present worth equal to 0. So here we have figure 7a5, which from the 14th edition of the textbook, which is similar to figures found in earlier versions of the textbook. But we have an 8% external financing rate. And so what we're looking at here is we have some cash flows, money we have to pay out in the future. And the question is, how much would we have to have now if we were going to borrow it now so that we would have it in the future? And we would have to pay an external financing rate to get that. So that's the 8%. And we use that to find the present value of the money going out, the negative cash flows. Then the money we're going to receive in the last few years is money we have in hand, and we can invest that at a higher rate that the company can get and find out what the future value is in year 7. And we're going to use 15% for that. So if you use the MIRR function in Excel and show the cash flows for year 0 through 7, that's the coordinates cell values B4 colon I4, and then the external financing rate is in cell A1 and the external investing rate is in cell A2, then the function gives us the answer, which is 13.64%, shown in cell A5. So this is a more realistic estimate of the internal rate of return on this project for comparison purposes and decision-making purposes.